In this video, we're going to continue our review by looking at finding the indicated terms in each question. This is question 3 from the review packet. Here I've been given a sequence, 12, 15, 18, and then I've been asked to find ace of 25. So the first thing I need to do is go ahead and write an equation. And in order to write the proper equation, I have to know what type of sequence I'm looking at here, if it's arithmetic or geometric. So I have to find the pattern in order to do that. So to get from 12 to 15, I'm going to check to see if I can add to get there. We can add the number 3. And to get from 15 to 18, I can also add 3. So it looks like plus 3 is my pattern, which means this is arithmetic, and I have a d value of 3. That also means that the general form of an arithmetic function, which is a sub n, equals dn plus a sub 0. If I was going to write an equation like this, I know the d value to plug in. I just need to find the a sub 0 pattern to plug in, or the value to plug in. So I know this d value, which is right here. All I need now is a sub 0, and to find a sub 0, all I have to do, because this is my first term, 12, all I have to do to find a sub 0 is move backward one spot from the number 12, according to my pattern. So the number I would have added 3 to get to 12, or if I subtract 3 to move backward, would be the number 9. So that means a sub 0 is going to be the number 9. So I can go ahead and create my equation. So a sub n is going to equal 3n plus the value 9. And with that equation, I can go ahead and find the 25th term by just plugging in 25. A sub 25 equals 3 times 25 plus 9. 3 times 25 is 75. If I add 9, that means a sub 25 is going to be the number 84. Let's go ahead and try this for question B and see what we get. For question B, again, before I can create an equation, I need to know what my pattern is. So if we check out this pattern right here, to get from negative 2 to negative 6, I would have to subtract 4. But to get from negative 6 to negative 18, I'd have to subtract 12. So it's not arithmetic. That pattern won't work. Let's see if I can get there through multiplication instead. So one of the ways I can do it is try swinging over using multiplication. To get from negative 2 to negative 6, I'd have to multiply by 3. And I can do the same thing to get from 18, to get from 6 to 18. The other method, if I wanted to check if it was r, is to use division. So I could do negative 6 divided by the term that came before. I would get that positive 3, and then I can check to see if it's the same thing in the next step, negative 18 divided by negative 6, and it is positive 3. So I now know for absolutely certain that r is the number 3. And because I have a geometric pattern with r, I'm going to need to fill in my geometric formula, which is a sub n equals a sub 1 times r to the n minus 1 power. So in this formula, I now know r, which is this number right here. I just need to fill in a sub 1, which is pretty easy because it's the number that was first in the sequence. So let's write out our formula. A sub n equals the first term, which is negative 2, times r, which is the number 3, to the n minus 1 power. And now I can find any term that I want to. So in this problem, I want to find a sub 12. So to find a sub 12, I just plug in the number 12. Negative 2 times 3 to the 12 minus 1 power. This is going to be a very big answer. I can plug that in my calculator, and the calculator tells me it is negative 354,294. Let's go ahead and try another one. Here's example C. We're going to go ahead and try to find the 77th term. Again, we're going to start by finding our pattern. Let's check arithmetic. To get from negative 30 to negative 25, I have to add 5. And then again to get here. So it looks like this is arithmetic, and I have a d value of 5. And we're going to go ahead and try to construct, again, that a sub n equals dn plus a sub 0 formula that you should have memorized. So I know my d value. I just have to go find a sub 0, which would be backward one space. I'd have to subtract 5 to find it. A sub 0 would be negative 35. So my equation would be a sub n equals 5n minus 35, or plus negative 35, which simplifies. Then all we have to do is plug in the number 77. A sub 77 is 5 times 77 minus 35, which would end up being in the calculator, it would be 350. Now we've got just one more to look at. So let's go ahead and find that pattern. To get from 4 to negative 2, I would have to subtract 6, but to get from negative 2 to 1, I would have to add 3. So we automatically know it's not arithmetic. Plus and minus do not count. They're not the same pattern every time. So let's go ahead and try and figure out if it's geometric. I don't necessarily, we could try to figure out what we have to multiply to move forward, and some of you can probably see what it is, but just in case we can't, instead of trying to calculate, instead of trying to see what this number is, let's go ahead and calculate it. So we'll find the r value by taking a term and dividing it by the one that came before. So I'll take negative 2 and divide it by 4, and if I simplify that, I get negative 1/2. If I get the same pattern here, that means it's geometric. So 1 divided by negative 2 is again negative 1/2. So I do have a geometric pattern, and we have an r value of negative 1/2, which means I'm trying to make it fit this pattern right here, this equation. A sub n is a sub 1 times r to the n minus 1 power. So I know what my r value is. I just need to go and find a sub 1, which is right here, 4. So I'm ready to write my equation. A sub n equals the first term, 4 times r, which is negative 1/2, to the n minus 1 power. And all I have to do now is plug in the n value I'm looking for, 14. A sub 14 is 4 times negative 1/2 to the 14 minus 1 power. This answer is also ridiculous. It's very, very ugly. You don't have to worry. The test shouldn't have anything quite, quite this nasty on it. But if you plug that in the calculator, the number you get is negative 0.000 and 3 significant figures, 488. All right. So that's it for finding those missing terms. Let's go ahead and take a look at finding the missing term in a sequence if we know what the first term is. We're going to check out question 4 before we move on to a new video. So we're going to be finding the missing terms in the following arithmetic sequence. We've started with the number 15, we've ended with the number 50, and we have 4 blanks in the middle. Now, finding the missing terms is as simple as finding D. D is going to be the key to this. D means the total change in value per term. So I don't remember how I phrased it in the lesson. It's all right. The change in value, I think I said value moved, per term. So all we have to do is figure out the total change in value and divide it by the total change in terms, and we should get our answer. To find the change in value, we can take a look at the difference between these two numbers. We went all the way from 15 to 50. So if I do 50 minus 15, I'll get the change in value. So 50 minus 15 is 35. For the denominator, we have to find the term. And the term is the number of times we've changed. So how many times did we move? And to find that, we can do our little bumps to figure out how far we moved. Or we can figure out what terms we're looking at here. We're looking at the first term, second term, third term, fourth term, fifth term, and sixth term. So we went from the first to the sixth, so we went a total of 5 terms. The other way to do that is to count the bumps. So if I said from 15 to here, oops, that's 1, 2, 3, 4, 5 terms that we've moved. So 35 divided by 5 is the only math we have to do. It gives us the number 7, and that's our D value, which means to get from term to term, all I have to do is add 7. So if we start with the number 15, the next term would be 15 plus 7, which is 22. The next one would be 22 plus 7, which is 29. Then plus another 7, we get 36. Plus another 7, we get 43. And plus one more 7, we end up at the number 50 that we had to start with. So we found all the missing terms by calculating D, which is the total change in value divided by how many terms it took us to get there. So how many jumps did we have to make? All right, we're going to pick up with finding missing terms without the first term in the next video.